Hello, welcome to Head Start Learning. My name's Ty. Today we're going to go over naming organic compounds, and then we're going to describe carbon chains. This is mainly focused on Organic Chemistry 1. This is really just to give those of you who are you could be in the class or about to take the class, just a good overview and an idea of what naming in organic chemistry is like. So I'd say if we're going to start with the very basics, we got methyl, which is one carbon, and that looks something like this. So a carbon covalently bonded to 3 hydrogens. Then we've got an ethyl, which is 2 carbons combined to one another. Then we've got our propyl, and finally our butyl, which is 4 carbons. So pretty much these are going to be, you're going to see these the entire time throughout Organic Chemistry 1 and 2. You're going to see them so much. I can't stress that enough. So you might as well learn these names now and commit them to memory. A good way to remember, because what a lot of people usually get tripped up on is the propyl and butyl. So a good mnemonic that people usually use is make every princess beautiful. And then if you want to add in pentyl, you can say make every princess beautiful, please. So, and a pentyl would be 5 carbons. So, essentially, it goes down. This is going to go down the line of pentyl, hexyl, heptyl, octyl, nonyl. Hopefully you can see the pattern. That's one thing about organic chemistry that you'll find out. A lot of it is really just a pattern. And the second you pick up on it, I can honestly say it gets very, very easy. So I'm sure you see things like this a lot whenever you hear about organic chemistry. They look like just, lines. But these lines actually do have good meaning. And you're definitely going to be seeing a lot of lines throughout your entire time there through the sequence. So these lines essentially are carbon chains. So where you see here in red are locations of carbons. And carbons are always going to be found at these points. So at every point is where you're going to find a carbon. So, if you want to go ahead and count through these, you got 1, 2, 3, 4 carbons here. Switch colors real quick. And 1, 2, 3, 4, 5 carbons here. And 6 carbons here. So you're pretty much going to count every point. Pretty much there's no arced lines you're gonna see. That won't be in that. You can't show it like that. Your professor will mark it wrong and with no remorse. So definitely always it will be very sharp pointed lines with very distinguishable points. And that is how you'll make your carbons. So these lines up here, these carbon chains, this will lead us into our first section, which is alkanes. These alkanes are essentially no double bonds or triple bonds. It's just a straight chain of carbons connected to one another. So these carbon chains, for example, like if this is our carbon chain, and I'm marking the carbons in red, this is essentially what this looks like, pretty much as a Lewis structure. I'll make that a straight line. Ooh, straight line. So that's essentially what that looks like as a drawn out, essentially. Every carbon is going to have the hydrogens surrounding it. Even though you can't see them on the line structure right here, they do have hydrogens bonded to the carbons. It may not look like it, but they're there. Always will be. Well, typically, unless otherwise stated or bonded to something else, the carbon could also have, other atoms bonded to it. So we're going to get into naming these alkanes, which it's actually really easy. So we're going to still look at, this is where our methyl, ethyl, propyl, butyl. No, we'll just leave it there, propyl, butyl. This is where these are going to come into play, especially with naming. So remember, these are our alkanes, or we're naming alkanes here. So really, we're just going to take the aim and we're going to slap it on the end. We're going to slap it on the end here of the methyl. And that'll give you that known structure of methane, which is a single carbon. A single carbon. And then our ethyl will be ethane. Again, just two carbons bonded to one another. No double bonds, no triple bonds, just a single bond. That's what alkanes are known for. Alkanes are single bonds throughout the entire parent chain, or throughout the entire carbon chain. Single bonds. So again, if we keep going down the list, we've got propane, which is just our 3 carbons. And then we've got our butane, typically the gas found in lighters, which is, again, 4 carbons. So that's really just something you're going to have to learn as you go on. So these are pretty much your basic alkanes. And then these can also get up to quite great lengths if you would like them to, or if they can get up to great lengths. So like 1, 2, 3, 4, 5. I'll mark the carbons for you in case. So 1, 2, 3, 4, 5, 6, 7. So that would be 7 carbons. And that would give us a heptane. Draw that out a little better for you. So that'll give us heptane. So we're gonna keep going through. So we've got our alkanes down. Pretty easy. You really just count up the number of carbons, and then we're gonna go back up to the top here, look at our list, and then essentially just throw an ane on the end, and then match it up with the number. Pretty easy. Nothing to fret about. Alright, so next up is our group of alkenes. So alkenes are essentially carbon chains with double bonds. Carbon chains with double bonds. And again, it still follows the methyl ethyl butyl. Excuse my handwriting here. Still follows the methyl ethyl butyl. Propyl butyl. And definitely again, just as easy as naming the alkanes. So for alkenes, here's a good example. I'll just mark these down so you can remember. So for alkenes, so they're gonna have a double bond on the carbon chain. So like right there, for example. So we're gonna count up our carbons. 1, 2, 3, 4. So 4 will give us butyl. So we're going to do but dash, and then we're going to count our chain. So we're going to see which way, going either this way or this way, which chain or how we're going to try to get the double bond on the lowest number possible. So in this case, it'll be 1, 2, and then we reach our double bond, and then going this way, it'll be 1, 2, then we reach our double bond. So it's the same way, it's the same number of carbons going both ways. So we're just going to throw that 2. So it'll be but 2 ene. That's the newer way to do it. Some professors also like this way, where it's 2 butene. Sorry, that looks bad. Butene. So this is another way to write that out. So we'll do some more practice here. So do this. All right, so we're going to count up our carbons again. All right, so here we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons, which will give us oct. Then we're going to find out, we're going to count both ways from the right and the left. So we got 1, 2, 3, 4, 5, 6. So we want to get our double bond on the lowest number possible. That's really the key here, is to get that double bond on the lowest number. So we're going to count from this way. 1, 2. So starting from the right side going over, we can see that our double bond is on the second carbon. So that'll give us oct 2 ene. Pretty easy. So next we're going to go and see what happens when we get 2 double bonds on a carbon chain. So again, very similar to this. We're going to have that double, we're going to have a double bond there and a double bond here. And then we'll kind of mark our carbons for you. Okay, so then here we're going to count up our double bonds. So we got 2 double bonds here, so we're going to count from left and the right side of the chain. So 1, 2, 3, 4, 5, 6. All right, and then we're going to count from the opposite way. And again, remember, we do want to get the double bonds on the lowest number possible for when we do make these, when we do name them. 2, 3, 4, 5, 6, 7. Okay. So as you can see here, our 2, 6 and 3, 4 and 5. So our 4 going from right to left is showing to be our lowest numbers. So here, and so we know it's 8 carbons, so we'd have oct 2, 4 diene. So a lot of things here in organic chemistry really just stem from the Greek, or just Latin, I guess. Die meaning 2. I guess another good example to really drive this home is if you were given 3 bonds on an octane, on a carbon chain. So let's say we got 1 here, 1 here, and 1 here. So we know that it's going to be the same going both ways. So I'm just going to count it from left to right. I'm just going to mark our carbons for us real quick. So 1, 2, 3, 4, 5, 6, 7, 8. And then if you wanted to count in reverse because you weren't sure, that's totally fine, because you can count in reverse and do 1, 2, 3, 4, 5, 6, 7, 8 from right to left. So then you're going to take your lowest number on each bond. So in this case, it would be this 2, 4, and 6. I'm going to do oct 2, 4, 6, triene, which hopefully all that makes sense so far. So next up, or hopefully you can see the pattern. It's pretty relatively simple. Not as daunting as many make organic chemistry out to be, honestly. So next up we got is alkynes, or the alkyne groups. And alkynes are triple bonds. Are triple bonds inside of carbon chains. So let's say we got so we got a hexine here. So we'll put our triple bond right here. So, oh wait, no, I'm gonna draw that differently. So, real tricky thing about alkynes that really gets people is they don't realize that there is 2 carbons here, because this is the one thing that defies the I guess it could be called the mountaintop rule, where you usually see at the points of these carbon chains is a carbon. So with alkynes, there's actually a carbon here and a carbon here that are subject to a triple bond, and there's also a carbon on the end. So this makes for some very tricky compounds that really trip people up on tests. I've seen it time and time again. So always be careful whenever you are seeing, or whenever you see a triple bond extended out like this, and note that there are 2 carbons on each side. So in this case, we'd have 1, 2, 3, 4, 5, 6 carbons. So we can count these out real quick. 3, 5, 6. All right, so we got that way, and then we've got 1, 2, 3, 4, 5, 6. So we know that starting from the left and moving towards the right, so following these numbers here, is going to give us our lowest number on that triple bond. So that should give us hex 2 ine. Again, it could be, if your teacher is really into this, it could be, 2 hexine. But it is a lot more specific to just, when you start doing larger and larger naming, to just put the 2 in the center with the hex and the ine in between the 2. It does make it a lot easier. So now I guess I'll give you one more here with so again, count your carbons up. So these are pretty easy. So 1, 2, 3, 4. Oh, like I said, tricky right there. Tricky. 1, 2, 3, 4, 5, 6, 7. Sorry, recount that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So over here we've got 9 carbons. So we'll start counting from left to right here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. See, this is a good habit to get into, is counting your carbons early on. So when you do start to get bigger and more complex chains, you won't mix them up, and you'll see what I'm talking about later on, because it'll get pretty intense. So it's always good to just count your carbons now instead of later. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so as you can see, from left to right is our lowest, or it gets our triple bond on the lowest number. So this will give us 3 ine. Sorry, it's kind of rainy outside today. Actually, it's raining really hard. So here we have our practice problems. If you want to take a second, pause the video and try these out. I'm going to go through them real quick, and you can see if you got them right. So we got ethane, again, 1 carbon, 2 carbons. That's kind of just a straight line, you know. Butane, so we'll have that line, 1, 2, 3, 4. So that one's just an even longer line with a triple bond in it. And then octa 1, 3 diene. So we'll have 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. And then we'll have 1, and that'll be our 3. So that'll be our diene. And then if you want to name these ones down here, this will be 1, 2, 3, 4, 5, 6, 7. Again, I'm just counting these carbons here on the ends. 6, 7, so that'll be hept. Then we're going to go from right to left here, because I believe that's the shortest route to get to that double bond. So 1, 2, 3. Hept 3 ene. Then for this next one, remember, so this one's also a little tricky. So we do have a carbon on the end here, carbon here, and a carbon here. So that'll give us our 3 carbons, and then give us our prop. So we know there's 3 carbons, which is propyl, and then it's a triple bond, so we know it's propyne. And then we're gonna locate that triple bond, so it'll be prop 1 ine. And then on the end here, I just got a little ridiculous with it. If you count up all these carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 carbons should give you decane, which probably won't see, but again, it's just an easy way, or just here to help you count your carbons up.